In this video, we'll be looking into designing of the Turing machine to accept the given language. Here it is 0 power n and 1 power n, where n should be equal to 1 or greater than 1. So here, L indicates, the language indicates that the Turing machine can have any number of zeros followed by any number of ones, but then the number of zeros and number of ones should be equal, right? So here let's take let's assume a string. Assume w is equal to 1 2 3 4 5 6, yeah, 3 zeros and 3 ones. So let q0 be the start state, and then we have read write head, so to scan the input. So for every 0 we need to replace it by x, and for every 1 replace it by y. So after first 0 is replaced by x, we need to find its corresponding 1 and replace by y, as number of zeros should be equal to number of ones. So we need to repeat the same procedure for all other the second 0 and the third 0 in the W. So let's look into the steps which need to be considered for designing the Turing machine. So the first one is assume Q0 to be the initial state. In order to know the further moves, scan the symbol by read write head. Past symbol scan must be remembered by the machine, yes, and Turing machine has capacity to remember its past move. Change from one state to another only when there is change in symbol written, or if there is change in read write head movement. In doing this way, number of states in Turing machine can be minimized. Once all inputs are scanned, Turing machine will have the configuration W followed by B, where B is a blank. So on entering the final state, read write head can either move left or right. So let's start with a problem. So design of initial tape and condition. Let me write the design of initial tape and condition. So this is the tape, okay. So I have 0 0 0 followed by 3 ones, and then blank here representing that the string is between two blanks. So in order to start, firstly I'll write the values here: 1 2 3 4 5 6. Yeah, so I'll start from this 0. So in order to start from this 0, so in this 0, so firstly I'll replace 0 by x and move right. So next, if I move right, I have 1 here, right? I have 0 here again. So I can write 0 0 0 1 1 1. So here I am in, so as I have replaced the 0 by x, I'll move from Q0 to Q1 state. Okay, now we are in Q1 state. Here I have 0. So you need not replace the 0, because after first 0 is being replaced by x, you need to find its first y 1 and replace it by y. Till that time you need to just keep on recursively moving from left to right. So 0 by 0 and move right. Next I have 0 0 0 1 1 1. I come to this 0. Again I need to move right. Here I was in Q1 state. Here also I am in Q1 state. Next 0 0 0 1 1 1. Now I encounter 1 here. So when I encounter 1 here, I write change 1 to y and move left, because I have found the corresponding 1. So here it would be, initially I have changed this to x, right? And here I have changed to y. So I need here along with changing 1 to y, there is a transition from q1 to q2 state. So now that I have obtained y, now let's start moving left. So x 0 0 y 1 1. So I'll move here 0 0 and left. Here also I get 0 0 and left. Next, when I come here, this part, so I have found for the first x, I have found the first equivalent y. So when I come here, it changes from q2 to q0 state. So once I'm here, I'll be in q0 state. Okay, x is done. So if I scan this, I get x over x move right, and when I come here, I get 0 is replaced by x and move right. In that case, from q0 state, I'm changing it to q1. So I can write this as let me draw a line here. So I can write this as x 0 y 1 1. So I am here now. So I'll replace 0 by 0 and move right. I am here. I'll replace y by y and move right. When I come here, I have to replace 1 by y and move left. I have, for the second x, I have found the second y. So I need to start moving left. So I'll get x 0 y y and 1. So for this x, for the first x I have found first y, and for the second x I have found the second y. I'll show the moves here. So I was here, right? This was changed to y. So when I come here, this part, this was changed to 1 y and left. When I come here, y and move left. This is 0 by 0 and move left. Here when I come here, I get x by x and move right. When you come here, this was in q2 state, this was in q1 state, this was in q1 state. From q1 state I changed to q2 by replacing 1 by y, and when I come here from q2 I am back to q0. Okay. So I have x 0 y and 1. So here I have x and move right. Here also I have x and move right. When I come here, I can write I can replace 0 by x and move right. Here I can replace y by y and move right. Here also I can replace y by y and move right. Here when I encounter, so here there's a transition from q0 to q1, and here I have the third one is encountered, right? So I can replace 1 by y and move left. So in this case from q1 it is changed to q2. So I keep on moving left till I encounter 1 here, till I encounter 0 here. So I'll write x y y. So for the first x I have found the first y, for the second x I have found the second y, and for the third x I have found the third y. Here let me write blank and blank. So whenever you encounter blank, it says that the entire string is being read. So for this string I have to draw the transition diagram now. So let me draw the transition diagram for this. So I have q0, q1 and q2 being the intermediate states. Along with that I'll have q3 also and q4 being the final state. So when I have in q0 state, 0 will be replaced by x and I'll move right. I'll move right till I encounter the first y. From x I should encounter the first y, right? So till then I should move right. So I keep on moving. So here there's a self loop condition. So when there's 0 and 0 I should move right. I need not change it. And similarly when there's y and y I should move right. And in q1 when I encounter 1 I should replace it by y and then start moving left to q0. So here also there's a self loop condition, that is on 0 and 0 I should move left till I get q0, and on y and y I should get I should move left till I encounter Q0. So here for Q0 I can write from Q2 to Q0 I should move x. I should replace x by x and move right. So this is in case of Q0, Q1 and Q2. And when in Q0, when I have y being replaced by y and move right, if I move right, I will reach the Q3 state. Here again self loop condition y, and r. And from Q3 to Q4, if there's a blank, so if I have blank, then I can move either right or left. And finally I'll reach the end, the final state. So this was about the transition diagram. Now I'll define the Turing machine. M is equal to Q cross Q comma sigma tau rho Q naught B and F, where Q comprises of all the states, Q0, Q1, Q2, Q3 and Q4 are the states. Sigma comprises of zeros and ones. Tau here has 0, 1, x, y and b. And then transition function, I'll define it. Q0, the start state is Q0 here, and B is the blank which belongs to tau star, and I have the final state or accepting state as Q4. So now let me write the transition functions for the given transition diagram. In order to write the transition functions, firstly I'll write the states on this side. So starting from Q0 state being the start state, Q1, Q2, Q3 and Q4. I have 5 states here. I've written it down here. And on this side I'll write all the tau values. That is either it can be 0 or 1, or it can be x, y and b. I'll compute a table for this. I'll start filling the values. So Q4 being the final state, I'll put a star here. Q0 on 0, it is changing to Q1, right? So I'll write firstly Q1, and 0 is being changed to x, and along with x it is moving right. So Q1, x and right. Then next from Q0, I have over y, there's a transition happening. Q0 over y, I am moving to Q3. Then I have y and r here. So I am done with Q0. Coming to Q1 over 0 I get Q1 itself. Here 0 and r. Q1 over y I get Q1, y and r. Q1 over 1 I get Q2, y and l. From Q2 over 0 and over y and over x, I have 3 transitions. Q2 over 0 I get same state Q2 only, 0 comma l. Q2 over y I get Q2, y and l. Q2 over x I get Q0. It is changing from Q2 to Q0, right? X and right. From Q3 I have self loop, that is y. From Q3 over y I get Q3, y and r, and over b I get Q4, b. It can move either left or right. So this was the transition function which I have defined here. My next step, I'll consider, I'll show you the sequence of moves made by made for string. Let me consider a string w is equal to 0 and 1. Firstly, I'll write the start symbol Q0 and I'll write the string 0 1 followed by B, that is blank, and I should do the instantaneous description in order to show the sequence of moves made. So I'll read it as Q naught on 0. Q naught on 0 I get Q naught on 0, transition of Q naught on 0 I get Q1 X and R. So Q1 X and R. So in place of 0 I should replace X, right? And Q1 should move right. So I can write X, Q1, 1 and B here. Now I'll consider Q1 on 1. Consider Q1 on 1. We get transition of Q1 on 1. We get Q2YL. So when we get Q2YL, move left, replace 1 by Y and Q1 to Q2. I write transition Q2. X will remain as it is, 1 change it to Y and B. Now I'll start again, 0 1 is done. Now I'll start Q2 and X. Transition of Q2 and X I get Q naught X and R. So I can write it as X, Q naught, Y and B. Again transition of Q naught and Y. Transition of Q naught on Y, I have Q3YR. So Y shift this side. So X, Y, Q3. From Q naught it is changing to Q3 and further move right. So again Q3 and B. So Q3 on B I get transition of Q3 on B. I get Q4B LR. So I can write X, Y, I get Q4 and B. So Q4, X, Y, Q4, B. Yeah. And along with that, left or right, it depends. So I can write this as X, Y, B followed by Q4. This depicts that Q4 is in the final state. When Q4 is in the final state, we can say that the given string is valid. So this is how we show the sequence of moves made by the given string by considering the transition functions. So I hope you have understood how to construct the Turing machine model for any given language. If you have any doubts, do let me know in the comments and subscribe to my channel. Thank you.